Projectile motion deals with objects that are falling, thrown, that are basically going through the air with no force acting on them other than gravity. So if you take a ball and you throw the ball, you exert a force on the ball. But as soon as you let go of the ball, the only force acting on the ball is gravity, forcing the ball to come down. So that would be a projectile. A bullet gets launched from a gun, or fired from a gun. There's acceleration that goes in within the gun, and then once the bullet leaves, then it will continue at the same horizontal speed, and the only force acting on that bullet will be the force of gravity. And of course we're excluding air friction. There is air friction there, but we're only looking at forces, the force of gravity causing an object to fall. So that's how we define a projectile motion. Here I'll do a couple examples with projectile motion and showing you what formulas you can use, how to set it up, and so on. So here's this example. While standing by the edge of a cliff, Marissa throws her phone up at 21 meters per second. If she throws the phone from 1 meter above where she stands, so this is 1 meter, how far from her feet will the phone be after 5.2 seconds? So we take a look. What do we have? What are we looking for? Which formula we're going to use? I have initial speed, v1, or vi, I should say, 21 meters per second. I know acceleration, which is gravity, and that is going down at negative 9.8 meters per second squared. I have time. Time is 5.2 seconds. And I'm looking for displacement. The formula that I can use to solve this formula here. And so I can just double check. I'm looking for a distance to displacement. Yep, I have initial velocity. Correct. I have time. I have acceleration, which is gravity. I have time. So that definitely is the equation I want to use. So solving for d is 21 meters per second. 5 seconds plus 1/2 times negative 9.8 meters per second squared times the time of 5.2 seconds, all squared. Now this will be minus because this term on the right has a negative 9.8. So my displacement will be 23.296 meters. Negative. So that is the downward direction. So it left from her hand, and her hand was 1 meter above her feet. And so if this is 23 meters below her hand, this would mean distance from the feet 22 point, and I'll round it off to 3 significant digits, 22.3 meters below her feet. For the second part of the question, how long will it take for the phone to reach the bottom of the cliff? It's probably easier to just start over again and not worry about what we've done. We're looking for time. Displacement. Now remember, displacement is a bit different than distance. Distance is the total distance that you traveled. Displacement is net distance. So for this picture here, it will go up and then come back down, and once it passes the same place it left the hand, displacement is 0, and then it will continue down. So the displacement, when you throw something up and it comes down and all the way to the bottom of the cliff, it will actually be from the hand to the bottom of the cliff, or 93 plus 1 meters, 94 meters. So my displacement, I will say, is negative 94 meters because it's downward. I know my acceleration, which is gravity, and that is negative 9.8 meters per second squared. I know my initial velocity, which is 21 meters per second. And so I take a look, and it looks like we'll be using the same equation again. However, this time it will get a little trickier because we're solving for time, and time shows up in two of the terms. So first we can plug this in. And now I will simplify and rearrange. So move everything to the left, and if I do that, I get 4.9 t squared. That's from this 1/2 times negative 9.8. So that's negative, and so if I add it to both sides, on the left it's positive 4.9. Then I get negative 21t minus 94 equals 0. So we have a square term and the linear term here, and so the only way to go around or to solve for this is using the quadratic equation, which some of you may know and some of you have learned. So using that format, which is like the one above, this is my A term. This is my B term, that's my C term. The formula for the quadratic equation is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So now we'll substitute for what we have. We're actually solving for t, and t, negative b. So negative of negative 21 is 21 plus or minus the square root of negative 21 squared minus 4 times 4.9 negative 94 for 2 times 4.9. As you can see, I've skipped a couple steps here. I've laid all the work for you, but I just paused my screencast to work through and save some time. And so we have 21 plus or minus square root of these terms here. Now notice it's a plus or minus, and so you're left with a decision. And sometimes it's a little trickier. This one's pretty straightforward because if I took the negative term, then my answer would be negative, and you can't get negative time, although some of us wish we could, but we can't, which leaves us then with a positive, and if we work it out, then the total time from the time she let go of the phone up in the air, goes up, comes all the way down past her, all the way to the bottom of the cliff, all that takes 7.02 seconds. Now we won't be doing a lot of the quadratic equations in Physics 11, mostly because you don't cover it in math until later on in the year, but it may come up, so make sure you are familiar with the equation and how to plug it in. More common of the projectile type questions that you should be able to do is one like this one, where you have a cannon firing a cannonball off the edge of a cliff. The cannon is 65 meters, and we'll say it is at 65 meters from the base of the cliff. We'll ignore the height just above the top of the cliff. it fires it off at 41 meters per second horizontally. How far from the cliff will the cannonball land? And the second, what will its velocity, or final velocity, be? So for the first part, you have to keep in mind that anything that travels in a horizontal velocity, that velocity never changes. We're not looking at air friction, and on a cannonball, it wouldn't be a ton of air friction. And so this velocity never changes. If you were to take a ball in space and you throw it straight ahead of you at 20 meters per second, that ball would continue on and on and on. If you're on Earth and you throw that ball at 20 meters per second, that ball also continues on and on. But at the same time, gravity pulls on that ball on Earth, pulls it downwards, and forces it to crash into the ground. So the reason it stops is because it crashes into the ground, not because it runs out of energy, not because it slows down. It's only because it gets pulled down and hits the surface of the Earth. So for this cannonball, we know the velocity horizontally is 41 meters per second. So I'm going to treat this actually as two questions. There's a horizontal component to look at and a vertical component. So the horizontal speed, the speed going horizontally of that cannonball, is 41 meters per second. Vertically though, when it leaves, its vertical speed is 0. It's the same as if you dropped it. So this cannonball, as it goes along here, it will take the same amount of time as if you had just dropped the cannonball. They would be at the same places. My diagrams might not be exactly right. They'll be at the same places at the same point in time, and just before they hit the ground, they'll be at the same place. Now the cannonball that gets fired horizontally will be traveling much faster because it's moving in two directions at the same time. It's moving horizontally, but it's also moving vertically downward, whereas the one that gets dropped only moves vertically downward. So its initial vertical velocity is 0. Horizontally is 41 meters per second. The first thing I need to find out is the time. How much time does this cannonball spend in the air? Because the entire time that it spends in the air, it's also moving at 41 meters per second. So to find the time, gravity and the height is what will tell me how much time it actually spends. So if I look at this equation, P equals VIT plus 1/2 AT squared, I have D, which will be 65 meters. I have initial velocity. If I am looking at vertically here, 65 meters, the initial vertical velocity, that is 0 because you got dropped. And the time is what we're looking for, and I know gravity will be 9.8. So for this question, nothing is going upward. It's just easier for me to say everything going down is positive. You don't have to do it this way. You can use negative 9.8, but I will say everything going downward is positive. So my gravity will be 9.8 meters per second squared. My displacement is 65 meters, and so on. So I will solve for time. If I rearrange this, first simplify, t equals 1/2 AT squared, and time squared is equal to 2D over A, where time is equal to the square root of 2D over A. So in this case, if I plug in the number, 2 times 65 meters over 9.8 meters per second squared, that gives me 13.265, and then I'll take the square root of that. Okay, and I'm trying to keep more numbers just to keep things more accurate. So that is the time it takes for the cannonball to hit the ground, whether it gets dropped from 65 meters or whether it's fired horizontally. Now, as I said before, the horizontal velocity of 41 meters per second, that never changes. So there's no acceleration to worry about. The horizontal distance, the distance it travels side to side, will be my horizontal speed times time in the air. So the horizontal speed was 41 meters per second. It spends a total of 3.6422 seconds in the air. And so this cannonball has traveled horizontally 149 meters from the base of the cliff. So the distance here, cannonball lands 149 meters away. Now what will its final velocity be? That one is a little bit trickier, because there are two components to velocity, and when we do vectors you'll look at that a little bit more closely. But this cannonball travels with a horizontal speed, which never changes, 41 meters per second, but also travels with a vertical speed. So the cannonball is actually traveling like that on the way down. Now the speed is changing over time. Initially, the cannonball only had a horizontal speed, and then it starts to gain a little bit of a vertical speed because gravity kicks in, makes it speed up in the downward direction, and the vertical speed keeps getting larger and larger and larger, affecting its overall velocity. We have the horizontal velocity. What we have to find out is what is the vertical velocity after 3.6422 seconds. So to find the final vertical velocity, and I'll use subscript y, I'll take the initial vertical velocity plus acceleration times time, and that is a vertical acceleration. So I'm looking for v, vertical y, final. It was dropped, which means its initial vertical velocity was 0, plus gravity is 9.8 meters per second squared, times time. I should just enter the time in now. 3.6422 seconds. And so the final vertical velocity after 3.6422 seconds is 35.694 meters per second. So that's vertical.
Mr. McKinnon, please contact the office. Mr. McKinnon, please contact the office.
Which means the overall velocity then, we have to add these two components, Vx, which is 41, Vy, which is going downward at 35.694, to find my overall resultant velocity. That will be the velocity of this cannonball. And so for this, I will use Pythagorean theorem. It will be v squared is equal to 41 squared plus 35.694 all squared. Which gives me a final velocity of 54.36 meters per second. Now, since this is a velocity, I also need direction, which means I need an angle, and I can use this angle right here. Because if I say this is going to the right is east, and going down is south, then this will give me an angle south of east. I just have to find out what that angle is. So if this is the angle I'm looking for, this is my opposite side, this is my adjacent side, and so opposite or adjacent means tangent. Tan theta is opposite over adjacent, or my angle theta will be inverse tangent of 35.694 over 41. And so that is an angle of 41.0 degrees. So finally, the velocity of the cannonball just before impact is 54.4 meters per second, and I will say 41.0 degrees south of east or below the horizontal. Keep in mind that this last part is actually pretty hard for Physics 11. This is something that Physics 12 should be able to do. So for Physics 11, I'd like you to be able to do this, but this will be on the upper end. So if I ask you a question, it will be probably the hardest question I will ask you. What you do need to know from this question, you definitely have to be able to calculate how much time the cannonball spends in the air and where it lands, 149 meters away. As far as the velocity with vectors, it is a harder question.